So today we are going to continue with networking. So we were discussing about the logical link layer. So, but the biggest topic is always what you get a question in second paper is the subnetting. Okay, so therefore today we are going to do the subnetting, and next time again we are coming back to the physical layer theory part and network layer theory part. Okay, anyway, I have given you the big overview, so therefore we have no issue doing the subnetting. Okay, so remember I told you that in the OSI architecture, or you have the 5-layer architecture. So here you have the MAC address. This is your link layer, logical link layer, and in network layer we have concept called IP address. Remember, MAC address has two portions, the vendor ID and the serial number. Actually subdivided into 4 and 4, 8, but ultimately it has two logical parts. So these MAC addresses, by looking at a MAC address, we can't get any feeling about where this machine is in the network, which area. But we have another concept in network layer, that is IP address. So IP address is more versatile, more flexible value. So using IP addresses, so MAC address is good enough for switching. So in switching, your switch must know only which machine is connected to which physical port. That's all. It's a very simple thing, right? So it knows, okay, this MAC address is for this physical port, this MAC address for this physical port, say physical port 1, 2, 3, or if it is wireless, these channels. So your switch has a table, MAC address and the port. So if a data frame is supposed to go to this particular MAC address, it knows that, okay, it's supposed to go there. It's not a complex task. So therefore, this just any number is good enough. Even 1, 2, 3, 4, 5 is good enough for the switching. But when it comes to internet, there are thousands of computers and thousands of subnetworks are there. It is not switching. It is much more complicated task. Say this is one particular subnet, and it is connected to this one, and another subnet, another subnet, another subnet, and this has another subnet. Likewise, it's a sort of a very complicated things. Maybe this guy is sending a data targeting to this computer. So then it has to go get the help of this router, this router, this router, this router, and there are so many other alternative paths as well. Right? This router, if it goes like this, maybe a data packet has, or the routers has decided to route it like this. Okay, or maybe there's a connection like this also, right? Something like this. So therefore, routing is more complicated process. And also routers, when they look at the address, they must be able to determine which way that data packet must be routed. It is not switching, it is routing. So that is where we have the concept called IP address. Right? IP address. So IP address is a layer 3 concept. Okay, layer 3 concepts. So what are the concepts in layer 3 or the network layer? IP protocol is there. That is the main protocol in networking. The concept of IP address is there. And of course, the concept of routing is there. The switching is layer 2, routing is layer 3. And of course, the router is there. Those are the 4 main concepts in network layer. IP protocol, actually IP protocol determines all these address formatting, routing techniques, and other things. Okay. Then the routing and the router. Of course, when it comes to routing, there are a few concepts like unicast, multicast. Let's do that when they publish the note, right? But today we are only focusing on subnetting. Okay, subnetting. Right. So subnetting is all about how we can allocate these IP addresses in a very systematic way so that routers can route it. By looking at the IP address, routers can determine, should I route it this data packet this way, that way, or the other way. Okay. And it is data packets. I forgot to mention another one. It is data packet. In link layer, we call it data frame. But in network layer, we call it packet. Sometimes maybe few frames are connected, considered as one packet in the network layer. Okay, right. So what are the 5 main concepts? IP protocol, IP address, routing, router, and data packet. Okay, main concepts. Right. Now let's dig into these IP addresses. Right. So these IP addresses are defined by the format, and everything is defined by ICANN. Right. International Consortium for Assign Name and Numbers, right? ICANN. So they take care of everything about the internet as a network. Remember, we have W3C, World Wide Web Consortium. So they are specifically looking after the World Wide Web standards. It's application of the internet. But as infrastructure, right? Overall infrastructure related decisions are taken by ICANN, right? International Consortium for Assign Names and Numbers, and one of the numbers they are interested is IP address, and names that they are interested is domain names. Right? Domain names. So we discussing more about domain names when you are discussing the application layer, because DNS is application layer protocol. Right. So I can define the IP address formats and everything. Okay. And these IP addresses are given in a very systematic way, right? And it's controlled by ICANN, right? And different countries are assigned different ranges and blah blah blah. So there's a logic behind that. And also these IP addresses, we have now two versions. What is known as IPv4 and IPv6. IP version 4 and IP version 6. So still I'm not sure whether your notes are going to focus more on V6, but still be heavily focusing on IPv4. Your previous syllabus, it was pretty much IPv4 and a little bit of introduction into V6. Okay, the routing and everything was based on IPv4 and little bit of IPv6 were there. So I hope this time also it will be the case, because still the routing is pretty much at V4 level. We are in a migration from V4 to V6, but all the routers are pretty much routing based on V4 mostly. Okay. So today what we are going to discuss is how the routing is done at when the IPv4 addresses are used. Okay. Right. So the IPv4 address format has 4 components. 4 components. So we use it in decimal number as a decimal numbers. Each component is between 0 to 255. Each component is between 0 to 255. Okay, so therefore the smallest IP address is 0.0.0.0. The biggest one is 255.255.255.255. Okay, so you can't have IP addresses like 0.231, right? Nothing like that. Any of these components cannot be anything with outside the range of 0 to 255. Okay, in V6, of course, it's a different format, and it's written in hexadecimals, and also rather than dot, we use the colon. And V6 we will be discussing later, right? Separately. Here we are only concentrating on V4. So then someone will ask why there are 2 versions. The reason is we are now running out of IPv4 IP addresses. Initially, they thought that because we have only 4 components and each value is 0 to 255. So therefore, the number of IP addresses we can create is 255 into 255 into 255 into 255. That's all. And it's a big number. I think it's a few millions. But we have now more internet users than this, because every internet user must be given a sort of a unique IP address. Right now, we are not giving each internet user a unique IP address because of we are running out of there's a shortage. So therefore, a lot of people are sharing IP addresses. Okay, sharing IP addresses. In a way, it is bad thing, right? It make our life or the routing and everything more complicated as well. So that is why they came up with this IPv6, where we have plenty of IP addresses. We are not going to run out of IP addresses for another 1,000 years. Okay, it's a huge number of IP addresses. Okay, right. Now, if you want to look at the IP address, you just take your command prompt when you are connected to the network or internet, or at least for your network. Then you can just type ipconfig. ipconfig. So you will see all the details, not all the details, some of the details, and this is your IPv4 address given by your router. In my case, it is 192.168.110. So most probably you will be also having a number somewhere on 192.168.1 number. Most of the time, your routers will give you 192.168 numbers. We will discuss those things, but this is not my real. This is my private IP address. My real IP address right now is, if you want to see it, you can just type when you are connected to internet. Just type ipconfig. Sorry, just type what is my IP. What is my IP? If you just type what is my IP with spaces, even Google will say your IP is, so this is my IP actually, right now 112.134.243.153. So you may be getting a different IP, most probably, right? Most probably you will be getting a different IP than this, but there's a slight possibility that you will be getting this same IP as well, because there's IP sharing. Okay, so this is the IP address given to me by SLT right now, because I have connected to the SLT. Okay, SLT connection. You can see that it's one. So this guy is also saying that the same IP 112.134.243.155, and it says it's given by the Sri Lanka Telecom. Right, it's identified me as Ratmalana. Maybe that is from that area. I have been connected to their network. Okay, sometimes it says Colombo, sometimes it says Ratmalana, sometimes it says Maharagama, and blah blah blah. Okay, right. And you can even see that I have my location roughly, and I have been connected through maybe C line somewhere in Mathura to the main internet backbone. Okay, so you can see that all those details they get from not only from the IP address. Actually, each ISP provider has a database which exposes certain information to the others. Okay, so actually it's partially from the IP address, and some informations are published by the ISP providers as well to the other servers. Okay, but definitely by looking at the IP address, any router can determine at least which way. It may not be able to say exactly where this IP address belongs to. So for example, a particular router may not be able to say that it is Sri Lanka, right? But it may be able to say that if it has, say, few paths, right, this way, this way, this way, this way, by looking at the IP address, it can say at least this is the way it should go. Right? This is the way it should go by looking at the IP address. So why it can say like that? Because of the way we do the subnetting. So the subnetting is done in a very systematic way, and there's a concept called subnet mask. So it will, where that mask can look at it, and then it will see, it will find the way to route it, because Just like the switches have the MAC address table, the MAC address and the physical port. These routers, this is the switch. The routers have a routing table with IP address and the physical port that it should route that. Okay, and here it is MAC address. MAC address represent one machine, but here we have IP address which represent a sub network. Okay, so this is a complicated concept. Okay, so you have to gradually understand this. නූල් බෝල ටික ටික ලියා ගන්න ඕනේ. එකපාර වදින්නේ නැහැ. සමහරවිට වදිනකොට අවුරුදු දෙකක් විතර යනවා. routing වදිනකොට. repeat වෙවි ඔන්න ඊට පස්සේ වැදිලා තියෙන්නේ. හරි. just give me 1 minute. Right. So these routing tables, what they have is not the IP address of a machine, it is the IP address of a subnetwork. Right. So this side we have now, if you have a router here, so there will be a subnet here, there will be a subnet here, there will be a subnet here. Maybe data is coming from this side, right? There will be another subnet, and these subnet may be again connected. That is fine. That is fine, but it will determine should that data packet be routed towards this subnet, that subnet, or that subnet to this subnet. Okay, by looking at the routing table. So therefore, what you have in your routing table is not the IP address of a machine, IP address of the subnet. IP address of the subnet. So that is why our topic is subnetting. Right? So we will be discussing how to calculate the subnet ID, broadcast ID, and blah blah blah. Okay, so any questions? Because this is very complicated topic. At least this is the most complicated topic in your networking subject. Okay, it doesn't mean that it is impossible, but you have to have some serious effort to understand this. Okay, right. So anyway, by the way, networking is not my main subject. Okay, so when it comes to programming databases, right? So I have plenty of hands-on experience, web development, but networking, I also have only the theoretical knowledge. Okay, so therefore, of course, if you can ask any question, but I may not be able to answer all your questions. Okay, so in this subject, okay, so that also you have to keep in mind. But I will give my best to answer all the questions if you have any questions, because you should be have a lot of questions in subnetting. Okay, lot of questions in subnetting. Right. Okay. Right. So now let's see. So I told you the IP address format. So it is something like this. 4 parts are there. Each one is 0 to 255. Okay. Now I told you that we are in migration. So therefore what happens is we get both V4 and V6 address. Okay. So this is my V4 address. Okay. This is my V6 address given to me by my router. My router in the means my home router. Okay. To me. So your home router or your office router is assigning IP addresses to all the devices that connect to that router. So we call them the local IP address. Okay, local. Now you can see that I have been given assigned both V4 and V6, because now we are in a migration. The new routers are aware of version 6, but all routers very rare now. So these all routers know only V4, right? V4, they can manage or they can understand only with version 4. That is why still we are using V4 and V6 together. In the internet, there are some possibility of some old routers still working. So that is why they have not completely taken out the V4. So this now this migration has been there for, I think, about more than 10 years, or very close to 10 years. But in the future, I have no clue. Maybe you can do a Google search and check what is their plans are. Maybe another 2 or 3 years or whatever, they will say, okay, V4 is no longer supported. Everything is done in V6. Okay. So by the time almost all the routers will be, because when an old router is replaced, always when you replace, your new router is always V6 aware. But the good thing is all the new routers are both V6 and V4 aware. So that is why they can coexist. Okay. Right. Right. So let's discuss few more concepts related to IP addresses. So when it comes to IP addresses, there are two types of IP addresses. Okay. So I'm going to divide it in different ways. Okay. So one division is we have the local IP address and public IP address. Okay, so local IP addresses are the IP addresses your router can assign to local machines, and those IP addresses can be duplicated. That is why I told you that the local IP address I am having is this. Maybe you will be having the same IP address assigned to you by your router. That is fine. That is why we say local, right? And most of the time the routers in Sri Lanka, they assign IP addresses from 19 to 168. Okay, and of course there are some other ranges also. So that means out of the IP addresses, some ranges are allocated as local IP addresses, and rest of the ranges are allocated as public. So public IP addresses are given from public range or non-local range. Local addresses are given from the local range. Okay. So we will discuss why we have two type of addresses like local IP address and global IP address. So public IP address. Okay. So local IP addresses has meaning only for the local routers, right? And also these local IP addresses are not going to be routed by routers in the internet. So therefore, always, if you are sending a data packet, always we have to use our public IP address. But within our network, say there's a data transmission between, say, Wi-Fi network, this machine and this machine, these things are happening using the local IP address. Because within the network, local area network or your personal area network, each machine will be given a unique local IP address, right? Local IP address. Okay. Right. So then global IP addresses are the addresses that has a geographical meaning. For example, Sri Lanka is assigned a set of a range of IP addresses, which is subdivided to dialog, SLT, Hutch, etc. by the government. So there we have the TRC, Telecommunication Regulation Commission. So they manage these things, right? So likewise, every country is assigned a set of IP addresses, and these IP addresses are also designed or divided in a very logical manner, not just arbitrarily, right? So for example, our IP address range, India, the IP address range for India, Maldives, they are related, right? They are related. So that is why when someone look at the IP address, maybe somewhere from in Middle East, they will look at it as a South Asian IP address. They may not, that router may not look at it as a IP address belonging to Sri Lanka, but definitely it's going to look at it as an IP address belonging to something like South Asia. Then when it comes to a router, right, in the subcontinent, then only it may be able to say, okay, this is supposed to go to the Indian side, this is supposed to go to the Sri Lankan side or Maldives. So this is supposed to keep moving because that is where the Sri Lankan link is. Okay, it's not supposed to go this way. Okay, so that is based on the public IP addresses. Okay. Within the local area network, local IP address is used for routing. In the internet, your global for public IP address is used. And the other thing is, in the local IP address can be duplicated, but public IP address is, as a theory, at least not duplicate. Again, there's a way to duplicate, but within the same ISP, but your public IP address is not going to be duplicated in another machine in Japan or whatever. Okay, right. So then there's another concept. Okay, another concept. I'm just going through the basic concepts of IP addresses first. These IP addresses can be either dynamic IP address or it can be static IP address. Right? Dynamic IP address or static IP address. So static IP address means your computer's IP address. Actually, when we say your computer, it is your NIC card, your network. So therefore, if you have two networks cards, like you have one network card for the local area network wired Ethernet, another network card for the Wi-Fi. You will be having two IP address. The IP address for the Wi-Fi network and the IP address for the wired Ethernet network. So that is possible. Okay, right. So these IP addresses can be either static or it can be dynamic. So what is meant by static IP address? The IP address is statically, right? Statically assigned to you. Again, there are two meanings. Okay, I will say statically assigned. Okay, let's talk like that because there's a lot of overlapping. So your IP address can be statically assigned or assigned static or static assigned, or it can be dynamic assigned. So static assigned means that IP address is assigned in that machine, right? For example, your IP address is configured by your machine, right, in your computer. Okay. Dynamic assign means you are not configuring the IP address, or the individual machines are not configuring their own IP address. Say this is the router. Now static IP address, static assign means this machine is configuring its IP address. This machine is configuring its one. You are not getting the IP address from the router or anywhere else, any other server. So that every machine, or some machines are, say this machine has configured its IP address. That means we in this computer, this node, we have static assigned IP address. But maybe this computer, when it connect to the network server or the router send that IP address and which you assign yourself. That means dynamically assigned IP address. Right? Dynamically assigned IP address. Right? Okay. For example, in my case, I have a dynamically assigned IP address. So this IP address is given to you by my router. Okay. So if I restart or if I disconnect and connect my computer again, right? Disconnect and connect my computer to the network again, maybe I will be getting different IP address. Maybe 192.168.111. Okay. So that is what is meant by dynamically assigned. Right? Dynamically assigned. So the IP address is given to you dynamically from the network server or the router. Okay. Now this is dynamically assigned. You can double check whether your IP address is statically assigned or dynamically assigned by going to the say network. Say go to the properties, and usually you have to go to, this is my Wi-Fi network, and properties, right? Properties, then go for the you can see something called TCP IP. You can see Internet Protocol version 4, and go to the properties. You can see here, choose an IP address automatically. So that means that is the default configuration anyway. in my computer, when I connect to this Wi-Fi network, my computer, my laptop, obtain an IP address automatically from the server or the router. But if I want to assign an IP address by myself, then I have to use this use static IP, use the following IP address. Then you have to type the IP address, subnet mask, default at the default gateway. Okay. And also you can assign what is your preferred DNS server and alternate DNS server. Okay. So we will be discussing those things gradually. Okay. But in my case, I have used this one, right? Obtain an IP address automatically. So that means I am getting the IP address dynamically by my router. Okay. If I select the other option, I'm getting IP address. I'm not getting IP address. I have assigned my IP address by myself. Okay. In that case, you have to make sure that you do not assign the same IP address to multiple computers in the same network, because then the routers will find impossible to route because there are ambiguities. Then of course you will be getting errors saying your IP address is duplicate file. Okay. Right. So that is one concept. Statically assigned IP address versus dynamically assigned IP address. So another concept is you have a dynamic IP address and static IP address. It's slightly different. Having a dynamic IP and having a static IP. So earlier, static assigned IP, dynamic assigned IP. So static IP means your IP address does not change. Your IP address does not change. So that is what is called static. And of course, if you have static assigned IP address, that is always static. Because when you assign IP address, it's how can it be wrong? Go change. How can it get changed all the time? Unless you change it. So therefore, statically assigned IPs are always static IP. But it is not a must. You can configure your server, network server or router also such that it will always give you the same IP address. So then also you get the static IP. Right. So whenever you connect, your router will give you, or your network server will give you the same IP address, which is configured in that network server. So you can configure that this particular MAC address, this is the IP address. So then it will not be given to other machines. So that is a static IP. So static IP can be from when you have a statically assigned IP, or your server is always giving you the same IP address. So these servers are sometimes called how do you call it?
DHCP?
Yeah, DHCP. Yeah, so I was looking for that one. Yeah, so those are called DHCP. Yeah.
Host configuration.
Yeah, dynamic host configuration protocol. So that is the protocol we use. So that DHCP protocol is used to communicate these IP addresses and also MAC addresses also. So the first option is you have statically assigned IP address and therefore your IP address is static. The second option is you have configured a specific IP address for yourself, for your MAC address, and therefore whenever you connect to the network, your server or network server or the router will always giving you the same IP address which is configured. So that communication is happening through a protocol called DHCP, Dynamic Host Configuration Protocol. So this DHCP protocol is used to send these IP addresses to, or assign IP addresses to the nodes. But if it is a dynamic IP address, always your network server will send you a different node. It is not a must, but there's a possibility of you are assigned different IP addresses, right? So anyway, if the IP address is given to you, whether it's a static or dynamic by the server, it's always happening through the DHCP protocol. And sometimes your router is said to have, it's running a DHCP server, right? So that means your router can be not just a router. It's a router, it's a DHCP server. Okay, so DHCP server means it's manage these IP addresses also. And sometimes your router is just doing routing, and the DHCP server is a separate machine in the network. Okay, so there are some possibilities like that. Right. Right. So then someone will ask why we have two type of IP addresses. So that is obvious question. So why we can get a static IP address, then we can configure to get a dynamic IP address as well. So again, the simple answer is why we are getting dynamic IP addresses, because we are running out of IP addresses. That is one reason. That is the main reason. Okay. For example, you are not getting a dynamic telephone number, right? Your telephone number is your one. Your mobile number is not shared. And you are not getting different mobile numbers at different times, because they have plenty of mobile numbers, right? You have plenty of mobile numbers. So therefore, your mobile number, whether you don't use it for months, still your mobile number is mobile number. Right? Others are not sharing it. But unfortunately, we are running out of IP addresses. Right? We are running out of IP addresses. So therefore, though you have the internet connection, maybe you are not connected to internet all the time. Of course, these days, a lot of people are 24 hours connected to internet, but there are plenty of people, there are plenty of machines, right? So they are not always connected to internet, but they are at a time they connect to internet. So then what they do is they have they say your ISP provider has 100,000 subscribers, users, but they are given only say 50,000 or maybe 25,000 IP addresses. So then they can somehow manage these 25,000 IP addresses for all these, because all these 100,000 is not getting connected to internet at the same time. So when you are disconnected, your IP address is again available to be assigned to another machine, another customer. Okay, so that is why these dynamic IP address, the main reason for having dynamic IP address is that. And of course, even in a local area network, so when you have a dynamic IP addresses, you don't have to statically assign, right? Statically assign, you can get the IP address from the other guy. But again, since we are running out of IP addresses, most of the time when you are getting a dynamic, when you are getting IP address, you may be getting different IP addresses, especially from the ISP provider. For the local IP address, we don't have much issue, right? We don't have much issue. If you can easily assign to get the same local IP address, but getting the same public IP address is costly thing, right? Costly thing. So if you really need a static IP address from your ISP provider, you have to separately pay them and request for static IP address. So then they will provide it, right? I don't know how much you have to pay. I think it's quite a large amount, right? That you have to pay. I'm not very sure exact value, right? I think it's at least 10,000. Okay, I don't know. You can just give a call and ask them, saying that I need a static IP address. They will say exact values, because once I just checked Google search and I couldn't find whether they have published anywhere, even the SLT or Mobitel or, right? Maybe you can just do a small research, do a Google search, and maybe just give a call to the call center and ask, I need a static IP address, how much I have to pay. Okay, maybe little bit more than 10,000 or something. I don't know, but on request only they provide, on request only. Okay. Right. So then someone will ask, okay, why do you need a static IP address? Yes. So you need a static IP address if your IP address is bound to a DNS, right? Domain name. That is the place where you must have a static IP. All the other cases getting a different dynamic IP address is okay, right? That is not an issue for you. But if you are, say you have a web server in your local area network, right, which is accessed by people all over the world using a domain name like abc.com. If they access your web server through IP address, that is fine. Then also you have to time give them the IP address, because if your IP addresses keep changing, right? So there you have to inform each time you get a new IP address, you have to inform the people that this is my IP address now. So therefore, if you have a web server or something, and especially if it is bound to a domain name, you must have static IP, because then only you can publish it to all the DNS servers in the world, saying that okay, abc.com is this particular IP address. Otherwise, every time you are getting new IP address, you can't always publish, because usually publishing IP address DNS pair to all the DNS servers in the world takes somewhere 1 to 2 days. So only after 48 hours, we can guarantee that all the DNS servers have your details, because the DNS servers are not updated all the time about their IP address DNS. Okay, so they have schedules. So they migrate phase-wise gradually from one area to the other area, because DNS server upgrades or the DNS updates happens sometimes once a day, or maybe sometimes 2 or 3 times a day. Okay, so therefore it's not practical. So therefore in that case you have to ask for a static IP address from the ISP provider, then you can publish it, right? You can publish it. There's a way to publish it. You have to just provide that information to the person or the organization that you buy your domain name or purchase your your domain name. Then they will publish it, or they will give you a login where you have to log in and type what is the IP address. Then from that entry, they will take it and publish it, right? And you will be getting an email saying that we have published it, and wait for 48 hours for migration to complete. Okay, right. So the main reason is the lack of the IP addresses. Okay, but if you are just a user of internet, getting a dynamic IP address is not a big issue, because when you are sending data pack, when you are requesting a say web page, you are sending your IP address. So now your IP address is not all the time changing. If you disconnect and again connect only, it will be changed. There's a possibility of change. Okay, so therefore during the session, your IP address is not going to be changed. So therefore during that internet session, your IP address is stable. So therefore it's not a big issue. And sometimes it's a little bit more privacy also, because others cannot identify you by IP address, because you are having different IP address at different time. And also it's good for security also. If someone has tracked your IP address and try to hack you, so the next time when you disconnect and connect to the internet, that IP address is no longer for you. You have a different IP address. Now the other guy hacker has to again find out what is your IP address is. So therefore having dynamic IP address is not too bad, but especially for servers and other things, you must have a static IP address. But when it comes to IPv6, that issue is no longer there. Still, if you want, you can have dynamic IP for privacy and other reasons, but anyone who need can be assigned static IP addresses, because there are plenty of billions and billions of IP addresses in V6. Okay, right. Right. So I explain you the static IP, dynamic IP, IPv4 format, those things. Okay. Right. So now we are moving to the subnetting. So that is the most important part, and you have to pay a lot of attention to understand this concept. Okay. Right. So subnetting means how are we going to allocate IP addresses to these subnetworks? And sometimes this subnetwork can have another subnetwork. Right? That subnetwork can have another subnetwork. That is how it works. For example, now if you take SLT, all the people, they say they have given IP internet to the not only the home users. So they have given IP internet connection to some business organization. So all those networks are subnetwork of SLT. So then there's another subnetwork for dialogue. So likewise, if you take world level, so Sri Lanka, we can they will look at it as a one subnetwork. So therefore, it's subnetworks and it's subnetworks and it's subnetwork. That is how it goes. And inside a business organization also, we can have subnetworks, right? So our network, we can subdivide it into subnetworks and its subnetworks, etc. Okay, so it's a very complicated process, and we have to do it in a very thoughtful manner. Otherwise, your data, your computers will not be identified in the routing. Right. So I told you that IP address has 4 components. Now we are concentrated on IPv4. So there are 4 components, right? That is fine. But when it comes to IP address, forget about these 4 components. If you look at it as a one number, because for the routers, it is set of ones and zeros. It's set of ones and zeros. I forgot to mention why it is 0 to 255. Each one is 1 byte. So in 1 byte, you can have the smallest value 8 zeros, the biggest value 8 ones. So 8 ones means 255. So that is why the range is 0 to 255. Okay, because each value is 1 byte. So therefore, you can look at your IP address as this kind of a number where you have 4 bytes. Right, 4 bytes, something like this. Altogether, you have 32 bits, right? So this is for our convenience. We divided into this so that we can remember. But in reality, of course, this one also has a bit of meaning. But for routers, it is a 32-bit number, right? 32-bit number. Okay. So that 32-bit number, right, 32-bit binary number can be subdivided into 2 parts. So the left-hand side is called the network ID. The right-hand portion is called the host ID. Right. So that is how it works. Okay, it's something like when we say Nimal at say abc.com as an email address. So this is your domain and this is your email identifier, right? So another person in that abc.com will have say Kamal at abc.com. So this part, by looking at this part, they know that what is the domain. By looking at this part, they know what is the specific person. Okay, so similar thing. So your left hand side, right hand portion is your host identifier. This is to identify, say you are in a subnetwork. You are in a subnetwork. So your IP address, your left hand side will identify this subnetwork. And the right hand side will only identify who are you. So basically, for the outside world, they don't care about this. They only care about this. It's something like your postman. When you get a letter, they don't care the name. They only care about the house number and other rest of the stuff. Because his task is deliver the letter to the house. His task is not to deliver the letter to the specific person. That is beyond the responsibility of the postal service. So same thing, when your IP address is, when router is looking at your IP address, it's only interested about this part. It's not interested about this part because its task is deliver it to the relevant router. This local router is only looking at this part, okay? Host identifier and giving it to the different machines. Maybe they have different identifiers, but people, these outer routers are not interested in this file. So that is why we have concept called subnet mask. Okay, subnet mask. So mask, you know what is mean by mask? Mask is used to hide. So basically these routers will wear a mask and look at the IP address. Okay, wear a mask and look at the IP address so that it will see the network part, not the host part. Okay, but it is not as simple as that also, right? It is not simply don't look at this. No, there's a more complicated mechanism behind that. Okay, so that is why the subnetting is very complicated process. It is not that now when you are looking at the email address, you can say, okay, simply I am not looking at this part, I am only looking at this part. It's like a line, right? We have special character, we are not looking at this part, we are only looking at this part. So yahoo.com, gmail.com, right? cmb.ac.lk, blah blah blah. Of course, then we have character, and we are interested, the other servers will be interested in only this part. But when it comes to IP addresses, it is not like that. It is not just we are hiding this. No, we are not hiding that. We are doing a somewhat different thing. Once we apply that mask is also a number, it will generate another number, and that is your subnet ID. Okay, so therefore it is not simply not looking at that part. The mask is also a arithmetic number. Then there is a arithmetic operation and give a number, and that whole thing is the subnet ID. Subnet ID. So that is why I told you that this is a complicated process, right? You need to have a lot of thoughts in order to understand this. Okay, right. Now you can see that when I'm assign IP address, it's not only IP address I'm getting a subnet mask, subnet mask, and there's another one called default mask. Okay, so be prepared to think about those things, right? Hours and hours of thinking. First time මේ network subject එක කරන්න. හරි පැය ගණන් කල්පනා කරලා අන්තිමට ඔයාලට තේරුණා කියලා හිතුවට ඇත්තටම ගාණක් හදන්න කියනවා තමයි තේරෙන්නේ මට තාම තේරුනේ නැහැ කියලා. හරි. So that is another reason why I'm doing this upfront, because you have at least 1 month to think. Okay, 1 month to think. මොකද මේක එකපාර වදින subject එකක් නෙමෙයි සාමාන්‍යයි. Right. So now I already explained you that these IP addresses has two parts, the network part and the host part. In subnetting, what we do is we divide the host part into another two parts, right? Two parts, so that it ended up in 3 parts. We are not touching the network ID. We are just borrowing few bits from the host ID to make the subnet ID. Subnet ID. So then our IP address is subdivided into 3: net part, net ID, subnet part. Actually, this is not subnet ID, subnet part, and the host part. Okay, host part. So don't think that this is a subnet ID. Subnet ID is just a number, just like IP address. Okay, so it is like say 100, 35, 30, say 20, 200, 30 something. So therefore subnet ID is also IP address, but this is subnet identifier or subnet part. Okay, this is host part. Okay, so that is why I asked you that if you have any doubts, you have to ask those questions. Then the time that you need to spend will be less. Otherwise, you have to spend a lot of time if you really want to understand, or else you will go to the exam with a lot of doubts. So that is not good for your confidence. Okay, right. So idea is we want to divide this into 3 parts, right? 3 parts, right? So then someone will ask, how do you know where this division or කොතනද මේ දෙකට බෙදෙන තැන තියෙන්නේ? IP address එක කොතනින්ද මේක බෙදෙන්නේ? So that is where we have sub IP at classes of IP addresses. Right? So all these IP addresses can be subdivided into classes, right? Class A, class B, class C, etc. Okay. So what are those classes? We have 5 classes. Okay, 5 classes. Class A, class B, class C, class D, and class C. Okay. If your IP address is a class A IP address, that this margin is, now remember we have 4 portions, each byte, this margin is here. If it is class B, this margin is here. If it is class C, this separation is here. Okay. We call this first octal, second octal, third octal, fourth octal. Okay. So if it is class A, that separation is here. Right? That separation is here. And another way of telling that the separation is here is saying that default mask is 255000. Okay. So it basically says that your separation is here. If it is a class B address, your separation is at the end of the or in the very middle. So another way of telling is the default mask. Make a subnet mask enemy default mask. Then we make the default mask in yeah. Subnet mask. Make the default mask is 255.255.0.0 if it is class B address. That means your separation is here at the end of the second octal. If your IP address is a class C address, your separation of net ID and host ID is at the third octal, end of the third octal. And another way of telling that is saying that the default mask is 255.255.255.0. Right? So we are not interested in class D and class C because class D and class C has special meanings, special usages. So we are interested in subnetting. For subnetting, we use only class A, class B, and class C addresses. Okay. So class D is used for something called multicasting, which we will be discussing later. And class E, they have reserved for experimental purposes. For ICANN to do some research and experimental things, right? So we are interested class A, B, and class C. Okay. Now you can see network host class A, network host class B, network host class C. Okay. Another way is telling the same thing is the default mask is 255.0.0.0, default mask is 255.255.0.0, default mask is 255.255.255.0. There's another way of telling that, that is, we can say it is /8 number IP address. /8 means the margin is after 8-bit. Another way of telling this is it's a /16 IP address. 16 means after 16-bit your margin. Here another way is /24. Your margin is after 24 bits. Okay. So then which IP addresses? Now remember I told you that IP addresses, the smallest IP address is this, biggest IP address is 255.255.255.255. So now we must be able to identify which IP addresses are belonging to class A, which range is for B, which range for C. And we are not interested in D and E. If it is not belong to A or B or C, now we know that we can't use them for subnetting. Right. So class A IP address range is first octal value. We are only interested in the first octal by looking at the first value. Say IP, say this is my IP address. Local IP address 192.168.110. You just have to look at the first value find out what is the IP, what is the class. You don't have to look at anything else. By looking at the first octal, the number, you can say whether it's a class A, class B, or class C, or anything else. Okay. Every IP address is belong to one of the 5 classes, A, B, C, D, E, though we are not interested in D and E. Right? If it is class A, the first octal value must be between 0 to 127. Class B, 128 to 191. If it is a class C address, the value must be 192 to 223. If it is beyond 223 or 224 or above, it's either DOE. DOE. Okay. Now you can see what class is this one. It's a 192 IP address. 192 IP address means class C IP address. Okay. So that is my private IP address is a class C IP address. So that is the IP class private IP address. Now, if you look at my public IP address, it's a 112 address. So what is that class? This is my public IP address assigned to me by my ISP provider. So 112 is class A IP address. Okay, class A IP address. Okay. Right. So there's another way to look at understand it. Actually, the routers will see your IP address as set of bits. Okay, set of bits, actually 32-bit number. In that 32-bit number, if the first bit is 0, right, look at this 32-bit number, and if the first bit is 0, it knows that it is a class A IP address. Okay. If the first bit is 1 and second bit is 0, it knows it is a class B. Okay. If the first bit is 1, second bit is 1, and third bit is 0, it knows it's a class C. Okay. So that is why the range is between 0 to 127. Because when the first bit is 0, the smallest value is all zeros. The biggest value is 0 and all ones. So that is 0 to 127. That is why we say 0 to 127 is class A. So if your first bit is 1 and second bit is 0, the smallest is all zeros and all ones. That is 128 to 191. Okay. Again, the 0 value we don't take because we reserve it for a special purpose. Anyway, 120. So similarly, 110, the smallest is this, the biggest is this. That is how. You don't have to remember that, but I just won't mention that there's logic behind that. That the old one කොහෙන්ද මේ number ආවේ කියලා නේද? මේ number ආවේ අන්න ඒක විදියට තමයි අද number ටික දාලා තියෙන්නේ. හරි? But you have to just remember this range 0 to 127 class A, 128 to 191 class B, 192 to 223 class C. So why you are interested in which class that IP address belong to? Because the moment you know the class, you know where this range margin is. Okay. Net ID to host ID margin is. Okay. Any questions? So therefore, this default mask they don't give. They will only give you the IP address because you must be able to look at the IP address and check find out whether it's a class A, class B, or class C. Right? So therefore, in the exams, they will not give you the default mask. They will just give the IP address, and you have to remember which range is class A, which range is class B, which range is class C. Okay. And then you know that if it is class A, it is default mask is 255000, or the separation is at the end of the 8-bit. Blah blah blah. Okay. Right. Now then someone will ask, why do you have, or why they came up with this concept of class A, class B, class C? Right? Why did they separate the IP addresses into different classes called class A, class B, class C. Remember, it's all about where do you separate them, right? Class A is here, class B is somewhere in middle, in between, class C is here. Remember, this is net ID, this is host ID. Here also, this is net ID, this is host ID. Here for net ID, you have 8-bit, host ID 24-bit. Here net ID 24-bit, host ID 8-bit. Here 12-12. Sorry, 16-16. So the idea was originally, if we have very big networks with millions of hosts, let us assign a class A IP address to that network, or what address or address range. If it is a very small network, let's assign class C address, right? Class 1, class 2, class C. So class A, class B, class C. Right? For small networks, let assign class C. For big networks, let's assign class A. That is the idea. That was the idea. Right? Now, if it is class A, now you can see that we have how many bits? 24 bits. So that means there are this much of possible IP patterns. It's කොච්චර ලොකුද කිව්වොත් එහෙම class A network එකකට මෙච්චරක් machines තියෙන්න පුළුවන්. මේක realistic value එකකුත් නෙමෙයි. ඔච්චර ලොකු network ලෝකයකවත් නැහැ. And මේ smallest queue එකකට ඒකටත් 256ක් දාන්න පුළුවන්. හරි. 256ට වැඩිනේ computers තියෙන companies ඕන තරම් තියෙනවා. ඒත් 256ට වැඩි තියෙන company එකට class C එකක් දෙන්න බෑ. හරි. class B එකකට යන්න වෙනවා. සමහර ඒවා තියෙන්න පුළුවන් 65000ටත් වඩා තියෙන්න පුළුවන් ඉතින් නේද? එහෙම ඒවා ඉතාලම කලාතුරකින් තමයි වෙන්නේ. හරි 65000කට වැඩි computers තියෙන sub network එකක් හැදෙන්න තියෙන chance එක ඉතා අඩුයි. ඒක නම් practically ඔය class A කියන එක use වෙන්නෙම නැහැ. theory එකක් විදියට. And theory of have a class C and B, yes. Class C and B, yes. So then what about my IP address? My public IP address, 112. So I told you 112 means what? Class A. Okay, මට හම්බෙලා තියෙන class A address එක. ඉතින් මෙච්චරක් කර network එකේ computers ඉන subnet එකකට මම ඉන්නේ. ඔය ලොකු subnet එකේ මේක තමයි ඉන්නේ. නමුත් ඔක කැඩලා ඇවිල්ලා එන්නේ ආ. පොඩි වෙලා එන්නේ. Right. Okay, we know where the separation is. By looking at the IP address, we know what is the class. Once you know the class, you know where this separation, net ID to host ID separation is. Okay. So the idea was for big networks, let us go for class A. හැබැයි මෙහෙම දෙයක් තියෙනවා. ලොකු network වල වෙන කොටක් machine තියෙනවා. හැබැයි එහෙම network 256 හදන්න පුළුවන්. එහෙම network ඔක්කොම 256 හදන්න පුළුවන්. මේ වගේ machine ටිකයි දාන්න පුළුවන්. හැබැයි ඒ වගේ network මෙච්චරක් හදන්න පුළුවන්. මේක machine ගානයි network ගානයි සමානයි. 65000 ගානක් දාන්න පුළුවන් වගේ එක network එකට. ඒ වගේ network ලෝකෙට 65000 ගානක් හදන්න පුළුවන් internet එකේ. But this is very rigid approach. හරි. මෙහෙම rigid approach එකකින් මේ වැඩේ කරන්න බෑනේ. මොකද මෙතන machine 10ක් ඕන එක්කනටත් දැන් මෙහෙම 256ක් හම්බ වෙනවා. නේද? අනිත් ඒකට මෙච්චරක් ඕන වෙන කෙනෙක් මේ ලෝකේ නම් හොයාගන්න බැරි වෙයි. මෙච්චරක් machine ඕන කියලා ඉල්ලන කෙනෙක්. සහ අඩු ගානේ මෙච්චරක් ඉල්ලන කෙනෙක්වත්. So therefore they came up with another idea, that is subnetting. Subnetting. So subnetting means this host part, from host part we can borrow some bits to create subnetworks අර 65000 256 හරි 256ක් හම්බුණා කිව්ව මේ 256ම දෙන්නේ නැතුව එක්කෙනෙක්ට අපිට පුළුවන් මේක බිට් ටිකක් අරගෙන මේකේ පොඩි සබ් නෙට්වර්ක් 8ක් 4ක් 16ක් හදලා දෙන්න. එතකොට සමහරට නෙට්වර්ක් එකේට මැෂින් දාන්න පුළුවන් වලට IP address හම් වෙන්නේ 10ක් 8ක් වෙන්න පුළුවන් 16ක් වෙන්න පුළුවන්. Okay, so that is the idea. So this margin, remember, just give 1 minute. Just give me 1 minute, Mike. Okay. So the idea is, originally it was a sort of a very rigid idea, fixed size things. But now when we have the concept called borrowing some bits to create subnet, now it's much more flexible. Now it's much more flexible. So now we have two margins. So this is determined by your class, whether it's class A or class B or class C. And of course, it is determined by your IP address and or class, or you can say the default mask, because every class has a default mask. For class A 255.0.0.0, class B 255.255.0.0, and class C 255.255.255.0. Okay, pretty much the same. Class එක කිව්වත් එකයි default mask එක කිව්වත් එකයි මොකද class එකට එක default mask එක ගන්න තියෙන්නේ. Then how do you know what is where is this when you have IP address? මෙතන කොතනද මේක කොහොමද දාගන්නේ? ඒකට තමයි වට කියන්නේ subnet mask එක. So this is determined by default mask. This location you can find out by subnet mask. Subnet mask එකෙන් තමයි වට කියන්නේ. ඒක කියන්න ඕන. එහෙම නැත්නම් වාට කියන්න නැත්නම් එක්ක subnet mask එක දෙන්න ඕන නැත්නම් slash කියලා කියන්න ඕන මේක 18 වෙනි bit එකේ නැත්නම් 26 වෙනි bit එකේ 30 වෙනි bit එකේ කියලා කියන්න ඕන. එහෙම නැත්නම් එතනට අදාළ subnet mask එක දෙන්න ඕන. හරි? And the subnet mask is always, now remember there are only 3 default masks. Another default mask 255.0.0.0 class A, 255.255.0.0 class B, 255.255.255.0 class C. There are only 3 default masks. How many subnet masks are there? Subnet mask තියෙන පුළුවන් කීයද? ඔක්කොම තියෙනවා bit 32ක්. මේ bit 32 theory එකක් විදිහට ගත්තොත් එහෙම subnet mask එක මෙතන තියෙන්න පුළුවන් මෙතන ඕන තැනක තියෙන්න පුළුවන්. theory එකක් විදිහට. ඇවිල්ලා මේ 0 කියන තැනටම එන්න පුළුවන්. ඒ කියන්නේ එහෙම වෙන්න බෑ practical. ඒ කියන්නේ යාගේ subnet mask එක කෙරෝල්ටම ආව කියන්නේ if the subnet mask is if this margin is here, that means there is no network ID. If this line is here, there is no host ID. I mean, host ID එකක් නැද්ද? host ID එකක් නැති network තියෙන්නත් බෑ. නේද? ඊළඟ network ID එකක් නැති network තියෙන්නත් බෑ. ඒ කියන්නේ අඩුම ගානේ network වලට එක bit එකක් හරි තියෙන්න ඕන. host වලට අඩුම ගානේ එක bit එකක් හරි තියෙන්න ඕන. හරි. එතකොට අපි කෙරෝල් වල දෙක අයින් කරමු. අඩුම ගානේ එක host කෙනෙක් ඉන්න ඕන අඩුම ගානේ network එකට එක bit එකක් හරි තියෙන්න ඕන. නැත්නම් network එක හොයාගන්න බෑ. So therefore, after 1 bit, then second bit, third, fourth, blah blah blah, up to 31 you can go. So theoretically there can be 32 subnet masks. But practically this edge is not useful. This edge is also not useful. So therefore practically we have only 30 subnet masks. Actually, this one is also not practical, that you will learn later. Having the subnet mask border in the 31st location is also not useful. So therefore, effectively, you have only 29 subnet masks. Subnet 3 default subnet 3 නැත්නම් default mask 3යි තියෙන්නේ. subnet mask 29ක් තියෙනවා. නමුත් theory එකක් විදිහට 32ක් තියෙනවා. 32යි තියෙන්නේ. ඔයාට ඕන ගානක් එන්න බෑ. දැන් ගොඩක් වෙලාවට පටලව ගන්න වැඩේ තමයි IP address එකක් කියලා කතාවක් තියෙනවා. For example, this is 125.3 say 100 90 20. So this is your IP address. Your subnet mask is also like that number. For example, now this is my IP address and this is my subnet mask. The subnet mask ඔහොම වෙන්න ඕන කියලා දෙයක් නැහැ. Subnet mask එකට වෙන values දෙන්න පුළුවන්. But there are only theoretically 32 subnet masks are there. IP address 255 into 255 into 255 into 2. A number of IP addresses are there. Your IP address and subnet mask have the same format. Your subnet mask is also look like IP address. Right? Look like IP address, but subnet mask is subnet mask. IP address is IP address. Subnet, the only purpose of subnet mask is identifying where is this margin. This margin. Actually, the easier one is you just have to say this margin is after 5 bits, 8 bits, 12 bits, 20 bits, 30 bits, etc. So therefore, rather than subnet mask, the easier way is you just say slash 30, slash 25. Unknown කියන එක තමයි lazy වැඩේ. unknown කියන එක තමයි lazy වැඩේ. මොකද ඔක ඔය 32 එකක් වෙන්න ඕන. 32 එකක් වෙන්න ඕන. එක තැනක තියෙන්න ඕන. හරි? 1 වෙන්න පුළුවන්, 2 වෙන්න පුළුවන්, 3 වෙන්න පුළුවන්, 32 වෙන්න. 33 වෙනකන් යන්න පුළුවන්. මම කිව්වා 33 වුණාම ප්‍රැක්ටිකල් නෑ. 0 වුණාම ප්‍රැක්ටිකල් නෑ. 30 මම කිව්වා 31 වුණාමත් ප්‍රැක්ටිකල් නෑ කියලා. ඒක වාට පස්සේ තේරෙයි 31 වුණාම ප්‍රැක්ටිකල් නැති කියලා. ඒකන්ට ඇත්තටම ඕක වෙන්නේ 1 ඉඳලා 31 වෙනකන්. එහෙම නැත්නම් ඕක subnet mask 31ක් තියෙනවා. හරි? So what are those subnet masks? So these are the possible subnet values. Actually there are only 32 possibilities. One possibility is your subnet mask is always set of ones followed by set of zeros. Okay, so that is very important. So we have set of ones, something like this. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is a possible subnet mask. Out of that, theoretically 32 subnet masks. There's another subnet mask is say beta calling in pula එකක් 110 ඔක්කොම 0. ඊළඟට 1 ඔක්කොම ටික 0. ඊළඟට 1111 ඊට පස්සේ ඔක්කොම ටික 0. ඔහොම ගිහලා තව මේ හරියට එනකොට එන්න පුළුවන් 11111. ඔහොම 1 ටික උනාට පස්සේ ඔක්කොම 0 වෙන්න ඕන. හරි. So එහෙම නැතුව subnet mask එන්න බෑ. So subnet mask is always set of ones followed by set of zeros. ඊට පස්සේ ඒක තමයි අපි මේ කියන්නේ 255 255 say 255 ඊට පස්සේ අපි හිතමු මේ ඔක්කොම අටේ මේ යටත් එකේවා මේ යටත් එක මේ යටත් එකේවා ඊට පස්සේ අපි හිතනවා එකේ 4යි බිංදු 4යි එහෙම නොත් එහෙම කීයද 1 2 4 8 16 32 64 128 ඔන්න ටික එකතු කරාම මේක තමයි මෙතෙන්ට එන්නේ අන්න එහෙම possibilities 32යි තියෙන්නේ subnet mask වලට right. So therefore just randomly by looking at IP address, sorry, it's not IP address, by any number is not a subnet mask. If it is a subnet mask, valid subnet mask, when you convert that subnet mask to a binary, always you must have set of ones followed by set of zeros. Otherwise, it is not a valid subnet mask because there are only 32 possible subnet masks. Right? Right, and of course the 4 default masks are also can be subnet masks. That is a different thing. මට ඇත්තට මේ default mask එක තමයි subnet mask එකක් විදිහට ඇවිල්ලා තියෙන්නේ. එහෙනම් මගේ subnet mask එක default mask එකම තමයි ඇවිල්ලා තියෙන්නේ. ඒ කියන්නේ class C ගේ default mask එක තියෙන තැනම තමයි subnet mask එක ඇවිල්ලා තියෙන්නේ. හරි. That is fine, but that is not a must. Okay. Any questions up to that point? Any questions about the subnet mask, default mask? And this notation is called CIDR notation. Okay, CIDR notation. So this is the default mask is given in CIDR notation. Even subnet mask can be given in CIDR notation. Okay. For example, say 255, 255, 255, that is 383838, then maybe 10000 1 2 3 4 5 6 7 8. So what is this number? 1 2 3 4 5 6 7 1 2 4 8 16 32 64 100. So this is a valid subnet mask. This is a valid subnet mask because this is when you convert it to binary, you have 25 ones followed by 7 zeros. That is fine. But if you have something like 130 or something where here also 1, then that is not a valid subnet mask. Subnet mask එක එකේව දිගටම වෙද ඊට පස්සේ දිගටම 0 තියෙනවා. ආයි මේ 0 1 කලවම් වෙන්න බෑ කොහෙවත්. හරි? මොකද මෙයා පෙන්නන්නේ මාජින් එකක්. මාජින් එකක් පෙන්නන්නේ. නැත්නම් මෙයා මේක IP address එකක් නෙමෙයි subnet mask එක කියන්නේ. ඒ මාජින් තියෙන්න පුළුවන් 32යි. හරි? 32යි. So easier way to write it rather than this is make නම් අපිට කියන්න පුළුවන් /88824/25 කියලා ලියන්න පුළුවන්. එතකොට ඔයාලට හොඳටම තේරෙනවා මේකට එන්න පුළුවන් /1/2 up to /32 වෙනකම් විතරයි කියලා. එහෙනම් subnet mask එන්නත් පුළුවන් 32යි theoretically. හරි theoretically. Right. Any questions? Okay. Right. So then we'll do a bit of examples. Right. Bit of examples. And remember, we have class A, class B, class C. In class C, we know that our margin is the default mask is here. Net ID, host ID. So therefore, if it is a class C, remember we are borrowing bits from here to create the subnet. So therefore, for class C, the possibility of subnet mask are, or this margin can be in the 24th, 25th, 26th, 27th, 28th, 29th, 30th, 31st, 32. ඒකත් class C එකට ඇත්තටම subnet mask එන්නත් පුළුවන් 8යි. Because මේ margin එකෙන් දකුණු පැත්තේ මේ margin එක තියෙනවා. Okay, so therefore theoretically, if it is a class C address, your subnet mask for your CIDR notation, it must be 24 to 32 only because මෙයාට මේ පැත්තේ තමයි මෙයා කැඩෙන්න තියෙන්නේ. But if it is a class B, the default mask is here, or this is the net ID, host ID. Host ID is the bit gun. So therefore it has 8, 16, say 16, 17 up to 32. But class A addresses, we have more possible subnet masks or CIDR notations, that is /8 to /32. So ඒවට හරියන subnet mask එන්න පුළුවන් 24ක්. Subnet mask 24ක් එන්න පුළුවන්. මෙයාට subnet mask 12ක් 16ක් එන්න පුළුවන්. මෙයාට subnet mask 8ක් එන්න පුළුවන්. හරි. class C යට subnet mask 8යි එන්න පුළුවන්. class B යට subnet mask 16ක්. මොකද මේ පැත්ත දැන් 16ක් තියෙනවා. මෙයාට subnet mask 24යි. හරි. දැන් මේක දැන් ටික ටික complicate වෙනවා. හරි. So that is this so far what I explained is what is known as class full addresses. මේ class එක කියන concept එක පාවිච්චි කරලායි මෙච්චර කතා කරන්නේ. But there's another concept called classless addresses. That is why we have CIDR notation, classless interdomain routing. In that case, we don't care whether it's a class A or class B or class C. ඒක දැන්ට පොඩ්ඩක් අමතක කරන්න. දැන්ට ඉඳන් ඉන්න class කියලා කතන්දරයක් තියෙනවා කියලා. හරි? මොකද නැත්නම් ඔක්කොම පැටලෙනවා. හරි? දැන්ට ඉඳන් ඉන්නේ එහෙම තමයි. class කියලා concept එකක් තියෙනවා. class C නම් subnet mask එක මේ පැත්තේ තියෙනවනේ. class B නම් 16න් පස්සේ තියෙනවනේ. class A නම් 8න් පස්සේ ඕන තැනක තියෙන්න පුළුවන්. 8න් පස්සේ ඕන තැනක තියෙන්න පුළුවන්. So then someone will ask, how do you determine, okay, this is depends on the class නේ. ඒක කමන්නේ නැහැ නේ. ඔයා කොහොමද decide කරන්නේ මේක මෙතනද කියලා? ඒක decide කරන්නේ මේමයි. දැන් මේක ටික ටික ඔලුවට දාගන්න. එකපාර ගණන් හදන්නත් බෑ. Now say it's a class C address. Class C. That means your default mask is 255.255.255.0. Okay. So therefore this is your first margin. So this is your net ID. Right. So if you don't go for subnetting, your host ID has 8 bit. But now we are going to borrow, right, few bits from here. Then only it is going to be net ID, subnet ID, and the rest of the stuff is your host ID. කලින් host ID එකට bit 8ක් තිබුණා. දැන් සමහරට මේක host ID එකට bit 5යි, net subnet ID එකට bit 3යි වෙලා කඩාගත්තා. එහෙම නැත්නම් subnet ID එකට bit 2යි, host ID එකට bit 6යි. Or maybe subnet 4. Subnet ID also 4, host ID also 4. So how do you decide that? You can look at it from two ways. You can drive it by how many host IP addresses we need for a subnet. Subnet එකට machine කීයක් තියෙනවද කියන එක පැත්තෙන් අපිට drive කරන්න පුළුවන්. හරි උදාහරණයක් විදිහට කවුරු හරි කියනවා හරි මට ඕන machine 8 subnet ගොඩාක් හදාගන්න. එක subnet එකකට මට machine 8යි හදන්න ඕන. machine 8ක් නම් අපිට bit pattern කීයක් ඕනද? Say 1 bit, 2 possible values. 2 bit, 4 possible values. දැන් අපිට 8ක් ඕනනේ. 3 bits 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1. Now we can get 8 patterns. So that means if your subnet, each subnet, say you need 8 computers or 8 hosts, so then you need a minimum of 3 bit here. ඔයාට sure නම් 8කට වැඩි machine ඕන වෙන්නේ නැහැ කියලා. So if you get 3 bit here, now here you get 5 bits. Subnet එකට bit 5ක් හම්බ වෙනවා. එතකොට subnet කීයක් හදන්න පුළුවන්ද? දැන් මේ bit එක subnet වලනේ. 2 to the power 5 subnet හදන්න පුළුවන් එතකොට. So 2 to the power 5 means what? So 32. So that means if you break like this, you have 32 subnetworks and each subnet can have 8 hosts. ඇත්තටම ඔක 8 කියවට 8 නෙමෙයි. ඔක තමයි ඊළඟ වැඩේ. හරි මම සමහරවිට මෙහෙම කියලා එහෙම වුණාට මෙහෙම නේ. දැන් තව පොඩි කතන්දර ටිකක් පස්සේ කියන්න තියෙනවා ඒකයි යා. Right. Say I want not 8. I need 32 machines for each subnet. අපේ requirement එක තමයි හරි අපිට machine 32ක් ඕන. host 32ක් ඕන. හැම sub network එකේ. දැන් මොකද කරන්නේ? දැන් 5යි 3යි කියලා බෙදන්න බෑ. හරි. දැන් බලන්න ඕන 32කට bit කීයක් ඕනද? This is 2 to the power 3, 8. So then 3 bits. 2 to the power 4 is 16. So 4 bit is not enough. Then I can have only 16 patterns. 2 to the power 5 is 32. So that means we have, if they say maximum we need 32 IP addresses or host, you have to go for 3 and 5. Calling up again 5 and 3. Then 3 and 5. So now our subnetwork have 32 hosts. දැන් ඒ වගේ subnet කීයක් හදන්න පුළුවන්ද? ඉස්සර ගොඩක් subnet හැදුවා හැම 32ක්. දැන් subnet හදන්න පුළුවන් එහෙම 2 3යි. ඇයි මෙතනට තියෙන්න පුළුවන් 0 0 0 ඉඳලා 1 1 1 වෙනකම් bit pattern 8යිනේ. එක subnet එකකට දැන් machine 32ක් දාන්න පුළුවන්. හැබැයි ඒ වගේ subnet හදන්න පුළුවන් 8යි. ඔක 64ක් කිව්වනම් එහෙම 2යි 6යි කියලා තමයි කඩන්න වෙන්නේ. එතකොට එක subnet එකකට machine 64ක් දාන්න පුළුවන්. හැබැයි ඒ වගේ subnet හදන්න පුළුවන් 4යි. 0 0 0 1 1 0 1 ඒ වගේ මේක compromise එකක් කියන්නේ. So if you try to create big subnetwork, you can create only small number of such subnetworks. If you want to create lot of subnetworks, your one subnet will have only less number of things. That is, if you want to go by the fixed number of subnet or fixed number of machines in the particular subnet. Sometimes we can subdivide it differently. අපිට ඕන 64ක එක්කෙනෙක් ඕන 32ක එක්කෙනෙක් ඕන 16 දෙන්නෙක් ඕන අන්න එහෙමත් කඩන්න පුළුවන්. අන්න ඒක තමයි වැඩේ ඉන්ටරෙස්ටිං වෙන්නේ එතනදි තමයි. හරි? Okay. Now let's move on to our question. So this is our first question. A host node is given as 167, 199, 170, 82, 27. අනිවාර්යෙන් වගේ second paper එකේ subnetting question එකක් තියෙනවා. හරි? A-level ICT කරපුවා දන්නවා A-level ICT paper එකේ අනිවාර්යෙන් subnet question එකක් තියෙනවා second paper එකේ. ඉතින් ඕකේ තමයි BIT වලත් අනිවාර්යෙන් subnet question එකක් තියෙනවම තමයි. network paper එකක් නැහැ subnet question එකක් නැති. හරි? all network paper එක අනිවාර්යෙන් subnet question එක තියෙනවා. හරි? Right. So this is the question. This is not a big question. This is sort of MCQ question. Okay. Host node is given. Okay. So we'll take a small break. Okay. So we'll take a small break, and after the break, we'll continue. Okay. Okay. So we'll continue. Right. So let's do the first question. Right. A host node is given 167, 199, 170, 82/27. So that is CIDR notation rather than the subnet mask. Find the network ID, broadcast ID, number of hosts of the subnet that host belong. Okay. Right. So this is, I will explain what is a broadcast ID and network ID also here. Okay. Right. So first thing is this is a 168 number. So 168. Now let's assume we are conscious about the classes. So 167. It's one. Yeah, 167. Right. 167. So 167 number means basically it's a class B because 167 is between 128 and 191. Okay. So it's a class B address. That means middle, you have this net ID and the host ID margin is in the right after 16 bits. Okay. Right. It's a class B address. Okay. Let's keep that also in mind. And this is /27. So when it is class B, it is 24. This margin is at 24, after 24. So then we can borrow bits, right? So this is where is this margin is. Either you have to give the subnet type, subnet mask, or you have to give the slash notation. So it says 27. So that means 24 plus 3 bits. We have earlier we had 8 bits for the host. Now we have borrowed 3 bits for the subnet. 3 bits for the subnet. So that is why this is 27. So that means here we have how many? 5. Okay, 5. So that is how 24, 3, 5, 27, and 5. 27 plus 5 is 32. Okay, right. So any questions on that? And this says this host node, this is a host value, host IP address. Okay, this is a host IP address. And they ask to which subnet this host belong to. Okay, to which subnet this host belong to. Now, since this is a /27, we know that each subnet will have, there are 2 to the power 3 subnets are possible. 8 subnet. Okay, 8 subnet because we have 3 bits, and each subnet will have 2 to the power 5 machines. That is 32 machines. 32 addresses are there. Okay, but remember, out of these 32 addresses, two addresses are reserved. That is, when all are 0, we call it the subnet ID. When all are 1, in this portion only. Right? When all are 0, that is called the subnet ID. When all are 1, we call it the broadcast ID. And those two IDs are reserved. One thing is to identify the subnet. Other thing is, if a machine in this subnet need to send a message to all the device host in that subnet, it will send it to the broadcast ID. Okay, broadcast ID. So then the router will send it to all the machines, because destination IP address is the broadcast address. Then the router knows that I'm supposed to send this to every node. So therefore, the first IP address all 0 and last IP address all 1 is reserved. Okay. Right. Now look at our IP address. This is, it's clearly say this is one of the host node. So that is in between these two. Okay. So now what you have to do is, we know that all these things are happening in the 4th octal. So therefore, just you have to make this binary code. You don't have to worry about these three, because things are happening in the 4th octal, because it's a class C address, class B, of course it's a class B address. Class B near the 167. Oh, mathing right. Anyway, 16. Yes, it's a class B address. So therefore, I made a small mistake. So this is after 16 bit. 16 bit. But anyway, it is after 16 bit. But so therefore, this is 5. This is not 3 now, right? 16 na metan 5 giyama 27ක් නේ. මෙයාට එනවා කීයද? 16න් 5ක් ගියාම 11ක්. සබ්නෙට් වලට 11ක් තියෙනවා bit. හරි? සබ්නෙට් වලට bit 11යි, host වලට bit 5ක් තියෙනවා. හරි? Sorry, because this is a class B address. Right. So now, what we don't need this information for this question, because we are only interested in the given subnet. Right now, first convert, transform this into binary 82. Right. So if you transform this into binary, මේකේ මම වැඩි හොඳට binary කියලා මේක ඇත්තටම ඕන නෑ. මේක නිකන් වාට 167 199 170 ඔය තියෙනවා. මේක ඇත්තටම binary කරන්න ඕනේ නෑ. මේක අර ලස්සන පේන්න binary කරේ. So but you have to make this one binary 82. If you convert it to binary by keep dividing by 2, you will get this. You will get this. And we know that the 5 bits is your margin. මෙන්න මේ 5 bits වලින් තමයි මේක කැඩෙන්නේ. මෙතනින් තමයි එකක් කැඩුනේ. අනිත් එක ඒ ඇවිල්ලා class B හන්දා අනිත් එක කැඩෙන්නේ මෙන්න මෙතනින්. හරි? And this is one of the machine. This is one of the host node. Okay, this is one of the host node. The question is, what is the subnet ID of the network that this host belong to, and what is the broadcast ID of that subnetwork that this host belong? This is one of the host. Okay, so I told you that when you have a subnet, the first IP address is the subnet ID, last one is the broadcast ID. So therefore, how do we find the first one? In the subnet part, මේ පැත්තේ ඔක්කොම 0 වෙච්ච එක තමයි subnet ID එක වෙන්නේ. මේ පැත්ත ඔක්කොම 1 වෙච්ච එක තමයි broadcast ID එක වෙන්නේ. මේ bit වෙනස් වෙන්නේ නැහැ. මේ ඒකේ ඉන්න හැමෝගෙම මෙතනින් මේ පැත්තේ bits වෙනස් වෙන්නේ නැහැ. දැන් එහෙනම් මේ bits එක වෙනස් වෙන්න බෑ. So that is why we want to transform it to binary. So these bits are not going to be changed. But when all are 0, that is your subnet ID. When all are 1, that is your broadcast ID. And this is one of the ID. And of course, there are 2 to the power 5 possibilities. 2 to the power 5 means 32 possibilities. Out of 32, this and this one is reserved. And then there are 30 more possibilities. And this is one of them. ඔයිට අමතරව 10011 101 ගොඩාක් තියෙනවා. මේකත් එක මැෂින් එකක්. ඒක host IP address. අපෙන් අහන්නේ ID වෙන එකේ broadcast එකයි subnet එකයි. So make sure you don't change these, but make sure all those 0 that is your subnet ID. ඒ කියන්නේ කීයද? මේක වෙනස් වෙන්නේ නැහැ නේ. 168.199.170 is not changed. This is 1 2 4 8 16 32 64. So therefore this is our the subnet ID that this particular machine belong to. හරි. මේ 82 එක්කන 170 82 ඉන්න එක්කනාගේ subnet ID එක තමයි 170 ගේ 64. Then what is the broadcast ID of that subnet? So broadcast ID is when all are 1. But these things are not changed because this is a part of the net subnet ID. So what is this? 1 2 4 8 16 32 32 ඩොට් එකක් අඩු 31 ඊට පස්සේ මෙයාත් එකතු කරනවා 1 2 so actually it is 1 plus 2 plus 4 plus 8 plus 16 1 2 4 8 16 32 64 තාම මේක එකතු කරන්න 64 ඔන්න ඔක එකතු කරාම මේ වඩා 95. So that is the broadcast ID of the network where this host belong to. මෙන්න මෙයා ඉන්න host මේ host ඉන්න subnet එකේ broadcast ID එක තමයි ඔය දෙක තමයි ගන්න කියලා තියෙන්නේ. Network ID, broadcast ID and number of hosts. So number of hosts are, because we know that from here we have only 5 bits, so that means 2 to the power 532. That is 32 number of IP addresses are there, but number of hosts are 32 minus 2, that is 30, because 2 IP addresses are reserved, one for subnet ID and the other one for broadcast ID. Number of IP address කිව්වොත් 2 to the power a bit ගන්න. Number of host ලා කිව්වොත් දෙකක් අඩු කරන්න ඕන. මොකද IP address දෙකක් reserve වෙනවා. One for subnet ID, the other one for broadcast ID. හරි? තේරුණාද වැඩි? තේරුණ නැත්නම් අහන්න, I can explain it again. And I know that if someone fail network subject, most of the time they have not understood the subnetting. So then their confidence is very low. අනිත්‍යකත් පටලව ගන්නවා ඊට පස්සේ ඒක. Okay. Right. So now I am going to explain why we call it subnet mask. Mask කියනනේ හැමතැනම නේද? So now the question answer is given. Okay, answer එක ඉවරයි දැන්. දැන් මේ පොඩ්ඩක් explain කරන්න හදන්නේ. මොකක්ද ඇයි මේවට මේ mask කියන්නේ කියලා. Right? Right. So this is, now remember this is our one of the host machine. IP address of the host machine. So this is its bit pattern. මේ ඇවිල්ලා ඒ host machine එකක හරි මේ වගේ තව machine 30ක් තියෙනවා මේකේ. 00001 00010 ඒ තමයි මෙයා අනේ මේ ඇවිල්ලා 1 එක නේද? උතන ඉන්න ඇත්තම 00001 00010 00011 0010 ඔන්නෝම machine තව 30ක් එනවා. ඊට පස්සේ ඒතර මෙයා ඇවිල්ලා net ID එකනේ. මේ පැත්තේ එනවා 1111 ඒ ඇවිල්ලා broadcast ID එක. මේ අතර එනවා 30ක්. ওই 30න් එකක් තමයි මේ දුන්නේ. එතන 01 00010 එන්න පුළුවන්. Then ඇයි මේවට subnet mask කියන්නේ කියලා බලන්න හදන්න. Okay. So this is your IP address. So when you are sending a data packet to some other server or whatever, you will be having your data packet as your IP address and the receiver's IP address. හරි. ඔයාගේ IP address එකක් තියෙනවා, receiver ගේ IP address එකක් තියෙනවා. හරි. අපි හිතමු ඔයාට කවුරු හරි data packet ඔයාගේ IP address එක ඒගොල්ලන්ට දීලා තියෙන්නේ. හරි. say resolve වෙලා තියෙන්නේ ඔයාගේ web server එකක් එකද? දැන් මොන්නේ මේ IP address එකට data packet එකක් එනවා. හරි. මේ address එකට data packet එකක් ආවම that router is going to look at it where in the subnet mask. Subnet mask එකේ දාලා තමයි බලන්නේ. කොහොම subnet mask එක දාලා තියෙන්නේ? මේක subnet mask එක මොකද්ද? /27 කියන්නේ මොකද්ද? එකේව 27යි ඊට පස්සේ 0 ඒවා ටිකක් තියෙනවා. මේ තියෙන්නේ එකේව 27යි ඒ කියන්නේ 224. ඔක /27 කියන එක අර විදිහට කැල්කියුලේට් කරා නම් 255 255 255 224. ඒ කියන්නේ මෙන්න මේ නම්බරේ 255 මේක 10 පාදයට හරවුවොත් 224. Okay. So that is the mask. That is a mask. So when the router look at your IP address, it will look at the IP address to by where in the mask. ඒකන්ට IP address එකක් දෙනකොට mask එකක් දෙන්න. mask එකත් එක්ක තමයි IP address එක දිහා ඒ කියන්නේ IP address එක දිහා බලන්නේ බලන අය mask එක දාලා. හරි? mask එක දාලායි බලන්නේ. So now this is the IP address of that particular host and this is the mask for /27. Okay, so then the router is going to do an AND operation on the IP address and the mask. So then we know that when all are 0, right, always this portion is 0. This portion is 0. And we know that A.1 is A. එහෙනම් මෙතෙන්ට එන්නේ මෙයාගේ set එකයි හැම වෙනවා. මොකද A.1 is A, right? And this is always 0. And if you closely look at this, this is exactly the subnet ID. ඕකම තමයි subnet ID කියලා. හරි. So whatever the valid IP address in that subnet will be viewed as the subnet ID. When a router look at the IP address, that IP address, but by where in the mask. When a router look at the any of these 30 IP addresses by where in the mask, they all look this value. ඒ හැමෝම ආට පේන්නේ මෙන්න මේ subnet ID එක නම්බරේ විදියට. subnet ID එකේ නම්බරේ විදියට පේන්නේ. So that is why we call that the subnet mask. Right? So routers look at IP addresses by where in the subnet mask. So then එයාට ඒක 30 දෙනෙක් විදියට පේන්නේ නැහැ. ඒ 30 දෙනාම එයාට පේන්නේ අර subnet ID එකේ. ඒක එහෙම තමයි වෙන්න ඕන. ඊළඟට ඒ subnet ID එක තමයි routing table එකේ තියෙන්නේ. routing table එකේ machine 30ට IP address එකක් දාන්නේ නැහැ. ඒ machine 30 වෙනුවෙන් ඒ subnet එකේ subnet ID එක තියෙනවා. mask එක දාලා බැලුව ගමන් එයාට පේන්නේ අර subnet ID එක. ඒක routing table එකේ තියෙනවා. Now it make your routing table much more simpler. Right? Less entries. Okay, so that is the reason behind this concept called subnet mask, because a lot of students, they don't know why it is called subnet mask, how a particular router look at the IP address. They just are machine wage ඔහේ මේවා මේ ගණන් හදනවා. subnet mask කියලා subnet mask කියන්නේ ඒ කියලාවත් දන්නේ නැහැ. Right, so that is why we call it subnet mask. Right, so whenever router look at an IP address, it where the subnet mask and look at it, then what they can see is the subnet ID, relevant subnet ID. And if it knows the subnet ID, if it is in the routing table, it can route. It can route it. The routing route කරන්න පුළුවන් IP address තමයි ඉන්නේ අනිවාර්යෙන්. හරි. Okay. අයිති ඒ වගේ first address last address උත් එහෙම ගන්න පුළුවන්. නමුත් ඒක අපිට වැදගත් නෑ. අපිට වැදගත් වෙන්නේ මෙන්න මේ field එක දාලා and එකක් කරනවා කියන එක තමයි. ඇත්තට මේව අපිට ඕන වෙන්නේ නැහැ ඇත්තටම. හරි. මම මේ ටික අයින් කරන්න ඉන්නේ. මේව ඕන වෙන්නේ අපිට. අපිට ඕන වෙන්නේ subnet mask එක දාලා IP address එකක් බැලුවම අපිට පේන්නේ subnet ID එකට කියන එක විතරයි. හරි. මේකම අයින් කරනවා. මම මේක අනවශ්‍ය ටිකක්. Okay, so let's do another question. The very vidiයට question එක දිහා තියෙන්නේ. Given the IP of a host machine in a network as this, with the subnet mask of this. ඒ කියන්නේ අරකම තමයි question එක. Cidr notation එකෙන් දෙන්නේ නැතුව දැන් මට subnet mask එක දීලා තියෙනවා. margin එක හොයාගන්න. Again you have to find the network ID, broadcast ID, blah blah blah. Okay. Right. So now 192 is what? class එක ඇත්තටම ඕන වෙන්නේ නැහැ මේ ගණන් හදද්දී. නමුත් අපි යුතුයකමක් වගේ බලමු. 192 is class C. Class C. So that means the margin is in the third octal. Third octal එකේ තමයි default mask එක කැඩෙන්නේ. X network host subnet කඩලා නැති වෙලාව. එහෙනම් අපි subnet mask ගේන්න ඕන මෙතනින් මේ පැත්තේ. හරි මෙතනින් මේ පැත්තේ ආවිල්ලා තියෙන 255 224 දෙකේ පාදයට හැරෙවම අනිවාර්යෙන් වට වෙන එකේ සෙට් එකකුයි බිංදු සෙට් එකකුයි වෙන්න ඕන. එහෙම නැත්නම් ඒක වැරදි subnet mask එකක්. හරි. එහෙනම් subnet mask නම් අනිවාර්යෙන් එකේ සෙට් එකක් එන්න ඕන ඊට පස්සේ බිංදු සෙට් එකක් එන්න ඕන. හරි ඒකම corner IP address එක subnet mask වෙන්නේ නැහැ කියලා. Right. Now you can see that 224 is something like this. So that means your margin is at the end of the fourth octal third bit, end of the third bit. Okay. Now convert this one because make a cadena fourth octal can convert 200 to binary. When you convert 200 to binary, you will get this. Then what subnet ID one na මේ ටික වෙනස් කරන්නේ නැතුව හරි මොකද ඒ කියන්නේ මේ පළවෙනි bit තුන වෙනස් නොකර අනිත් bit ටික 0 කරන්න මේක තියෙනවා 0 කරන්න මේ පැත්තේ වෙනස් කරන්නේ නැහැ so that is your subnet ID මේක subnet mask එක දැම්මට පස්සේ පේන්නේ එහෙමයි මේක මේ IP address එක පේන්නේ මෙහෙමයි right මේ පැත්තේ තියෙන 0 ඒවා නේද මේ 1 එක 0 වෙනවා මේ පැත්තේ තියෙන්නේ 1 ඒවාන්ද 1.a ඒ හන්ද ඒක වෙනස් වෙන්නේ නැහැ and broadcast ID is මෙතනින් මේ පැත්තට ඔක්කොම 1 කරලා දාන්න. මොකද යාට අන්තිමට. So therefore you will get this is the subnet ID, this is the broadcast ID. And how many hosts are there? Because there are 1, 2, 3, 4, 5, 2 to the power 5, 32 IP addresses, 2 IP addresses are reserved. So therefore in this subnet there is a possibility of 30 hosts. Host la 30ක් වෙනකන් යන්න පුළුවන්. එකපාර මේ subnetting කරන්න නැතුව මේ පොඩි වටේ questions ටිකක් මේ කරන්න යා. Right question example 3. Right. The first and the last IP address of a network are so network means subnetwork. This one and this one separately. On කියන්නේ so first address means subnet ID. Last address means broadcast ID. Find the subnet mask of the network. On එකේ විදිහට මේක දෙන්න පුළුවන්. ආයෙත් අන subnet mask එක දෙන්නලු දැන් මේගොල්ලන්ගේ මේ network එකේ. Now you can see that here these are not changed 130 109. So therefore you don't have to worry about that. So therefore now you have to convert 48 into binary, 63 and 255 into binary. ඔන්න ඔය දෙක binary කරන්න ඕනේ දැන්. හරි? So when you convert 48 into binary, you will get this. And when you convert 63255, you will get this. Okay. Now you have to check. Okay. Because this is the first IP address. Because this is subnet ID. This is the last IP address. එහෙනම් දැන් මෙතනද හොයාගෙන යන්න ඕන කොතනද ওই මාජින් එක ඇවිල්ලා ඇත්තේ. මෙතන වෙන්න බෑ. මොකද ඔක්කොම 0 වෙන්න ඕනේ. ඔක්කොම 0 වෙන්න ඕනේ මෙන්න මෙතන. තේනවා. ඔක්කොම 0 වෙලා තියෙන්නේ මෙතනින් පටන් අරගෙන ඔක්කොම 1 වෙලා තියෙන්නේ මෙතනින් 1 තියුණා ඩඩක් නැහැ. මේකේ ඔක්කොම 0 වෙන්නත් ඕන. So therefore definitely the margin must have been here. එතකොට තමයි මෙයා first IP address එක වෙලා මෙයා අන්තිම IP address එක. එහෙනම් subnet mask එක මේක CIDR වලින් නම් කීයද? 888. So that is 88 and another 4. In CIDR, it is 20. If you want to put it as a subnet mask, 255255, මේ එකේ 4යි බිංදු 4යි ඔන්නෝම එන්න ඕන. එතකොට මේක දෙකේ 10 පාදයට හැරෙවුවාට 240 කියලා. So the subnet mask is going to be 255255240 because this is where the margin. Okay, this is where the margin. Okay. මෙන්න මේක තමයි ඔයාලට එක්සෑම් එකට එන ගාන. එක්සෑම් එකට එන ගාන කියන්නේ මොඩල් එක. හරි. මොඩල් එක. මේවයි ගණන් තමයි දැන් A level ICT paper එකෙන් දෙන්නේ. හරි. හැම අවුරුද්දෙම වගේ ඔන්න question එකක් දෙනවා. right. ටිකක් දිගයි ගාන. නමුත් ඒකත් හදමු නේද? එතකොට try කරන්න වෙලා තියෙනවා මාස 7ක්. දවස් දෙක තුනක්. Right. So this is the question. An organization use 192.168.10/24 network. මේ IP address එකක් නෙමෙයි IP address range එකක් මේ දෙන්නේ ආ. /24 කියන්නේ 255.255.255 තමයි subnet mask එක. default mask එක ගාම තමයි subnet mask එක. Following are the subnetwork requirements. So we have 4 departments. Department A needs 100 machines. Department B needs 50 machines. Department C needs 25 machines. And Department D needs 5 machines. Okay. The question is, design the subnets by giving subnet ID, broadcast ID, and valid IP range for each subnetwork. So we need 4 subnetworks. 4 subnetworks. Okay. Right. So this is the IP address we have. May IP address and IP address range are made in yeah. So 192.168.10. Okay. And it's a /24. Anyway, this is 192.168.10 එක මෙතනින් තමයි කැඩලා තියෙන්නේ. and මෙන්න මේ ටික අපිට සෙල්ලම් කරන්න පුළුවන්. මොකද subnet එක 24ක් කියන්නේ මේ අට අපිට සෙල්ලම් කරන්න ඉඩ තියෙනවා. Right. So we have 8 bit to play around. මේ 8 bit දිහා තියෙන host ලට. host ලට හරි. අපි තමයි ඔය host ලට තියෙන bit වලින් සමහර bit අල්ලගෙන subnet කරන්න හදන්නේ. නැත්නම් අපිට ගන්න පුළුවන් if you go for one big network, one big subnetwork, we can add how many IP addresses we get? 2 to the power 8. That is 2, 4, 8, 16, 32, 64, 100, 256 machines we can introduce. That is 256 IP address. That means 254 machines because we have to less 2. But our requirement is not to create one big subnetwork with 254 machines. Rather, create 4 subnetworks. Subnetwork හතරක් හදන්න ඕනේ. එකක් නෙමෙයි. 254ක් ඉන්න එකක් හදනවා නම් මෙතනින් කෙලිම හරිද? හැබැයි අපි දැන් මේකේ bit borrow කරගෙන මෙහෙම borrow කරගෙන subnet හදනවා. හැබැයි ඒවට cost ලා එතකොට අඩු වෙනවා. හරි. දැන් කාට හරි කියන්න පුළුවන් ඉතින් හතරක් ඉන්නවා නම් නේද? bit කීයක් ඕනද? එහෙමනේ අපිට සාමාන්‍ය හිතෙන්නේ නේද? So we need 4 subnetwork. So 4 subnetwork means if you just go by your gut feeling, you need to borrow 2 bits because 2 means 000111011. You have 4 subnetworks. 4 subnetworks. Okay. So therefore, now if you go by that, how many machines can be there in a one subnet? 1, 2, 3, 4, 5, 6. 2 to the power 6 is 64. So every subnetwork can have 64 machines. If you then you are creating equal size subnetworks, but this one need 100 machines. එහෙම කැඩුවොත් එහෙම මෙයාට මදි. එක සමානෙම කඩන්න ගියොත් මෙයාට මදි මේගොල්ලන්ට වැඩි. ඒ 64ක් දෙනා 5ක් ඕන කෙනාට. අපි වැඩිපුර තියනවනේ එහෙම දුන්නට කමක් නැහැ කියන ඉස්සරහට මේක grow වෙයි කියලා. හැබැයි මෙයාට දැන් වැඩේ කරන්න බෑ. Right? So that means we are in trouble. So therefore we can't just create equal size 4 equal size subnetworks. Though we need 4 subnetworks, we can't go for 4 equal size subnetworks because 64 machine is not enough for this particular A department. All the other departments will be happy, but department A is not happy. So therefore, we can't just break it like this. So in this case, what we do is we first look at which department needs the largest number of IP addresses. So you can see 100. If you need 100 IP addresses, how many bits you need? This is 2, 4, 8, 16, 32, 64, 128. So 128 තමයි හැමතිස්සෙම අපිට subnet එක හදද්දී දෙකේ බලවල machine ගානක් තමයි දෙන්න පුළුවන්. හරි? එයා ආස උනත් නැතත්. ඒ කියන්නේ ඔයාලට 5ක් ඕනත් අපි 8ක් දෙන්න ඕන. 9ක් ඕනත් අපිට 16ක් දෙන්න වෙනවා. 16 බ්ලොක් එකක් දෙන්න වෙනවා. හරි? ඒකත් මතක තියාගන්න. ඔයාලට ඕන 50යි වෙන්න පුළුවන්. නමුත් අපි දෙන්න ඕන ඔයාලට 64ක බ්ලොක් එකක් තමයි දෙන්නේ. හරි? මොකද එහෙම නැතු මේක බ්ලොක් හදන්න බෑ. So now you have 100, we can give 128 block. හැබැයි එතකොට bit 7ක්ම දෙන්න වෙනවා ඔයාලට. bit 7ක්ම දෙන්න වෙනවා. හරි? මොකද bit 7ක් තමයි 128 වෙන්නේ. So therefore what we have no other option. We are going to break it in the first or the first bit of the fourth octet. Okay? So then we have here 0, 1 possibility, other possibility 1. So we can allocate either 0 to the sales department or 1. So let's allocate 0. Right? So 0 කරාට පස්සේ ඉතුරු bits ටික යාට සෙල්ලම් කරන්න පුළුවන්. right? 0 එක දෙනවා අපි A ට 1 එක තියා ගන්නවා අනිත් පැයට. right? දැන් 0 එක දුන්නාට පස්සේ අපිට ගන්න පුළුවන් එයාගේ subnet ID එකයි broadcast ID එකයි. So the all 0 subnet ID, 0 all 1 broadcast ID. And of course 168.1.1 to 168.1.126 will be the possible IP addresses, host IP addresses. ඒක තේරුණාද? ඒතර subnet එක වෙන්නේ /25. හොඳට මතක තියාගන්න /25. මොකද දැන් මෙතනින් කැඩෙන්නේ. හරි? දැන් මෙයාගේ 24 තියුණා කියලා ගන්න බෑ. දැන් subnet එකේ subnet ID එක වෙන්නේ /25. නැත්නම් 255 කියලා හදන්න ඕන. හරි? 1.7ක් තියෙන නම්බරේ. දැන් බිඳුව කියන එක තමයි දුන්නේ. දැන් එක ඉතුරුයි අපිට. එක කියන එකේ ඉතුරු මේක අපිට සෙල්ලම් කරන්න තියෙනවා. දැන් එක කියන එක එක්කෙනෙකුට දුන්නොත් එහෙම සබ්නෙට් දෙකයි. එතකොට සබ්නෙට් දෙකක් හදාගෙන ඊටමත් දිනවනේ. හරි. බලන්න ඊළඟට කරන වැඩේ. දැන් එක කියන එක එහෙමම දුන්නොත් එක සබ්නෙට් එක. ඒතකොට සබ්නෙට් දෙකයි හදන්න පුළුවන්. සබ්නෙට් දෙකක් නෙමෙයි තව සබ්නෙට් තුනක් හදන්න ඕන. හරි. So therefore what we can do is now one is available. So next one we need ඊළඟට ලොකු එකනට ඕන machine 50ක්. machine 50ක් කියන්නේ අපිට යන්න වෙනවා 64ක් වෙනකම්. 2 4 8 16 31 64. ඒ කියන්නේ 6ක් ඕන. So therefore now we have the 1. So we can subdivide it to 1 0 and 1 1. And we can give 1 0 or 1 1 to the department B. Let's assume we give 1 0. So then these things they have to play with these things 0 0 0 to 1 1 1. The 1 0 තමයි අර දුන්නේ ආ. අපිට ඕන 1 1 දෙන්නත් තියෙනවා. ඒතකොට 1 0 අපිට ඉතුරුයි අනිත් ඒවා. So now this is the subnet ID, this is the broadcast ID of the department B. Okay? And now we have 1 1. 1 1 එක අනිත් එකෙන් දීලා හරියන්නේ නැහැ. ඒතකොට එක subnet එකද අපි subnet දෙකක් හදන්න ඕන. හරි? දැන් දෙකයිනේ හැදුවේ තව දෙකක් හදන්න තියෙනවා. ඒක හඳ මොකද කරන්නේ? 1 1 එක අරගෙන ඉවරලා අපි ආයි ඒක 0 සහ 1 කියලා කඩනවා. මොකද එතකොට අපිට ඒකෙන් තව subnet දෙකක් හදන්න පුළුවන්. 0 blah 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 1 blah blah blah. So we can say this is department C and this is available for others. Okay. So මේක එතකොට ගන්න 1 1 0 දාලා ඉවරලා ඊටු ටික 0 කරාම එයාගේ subnet ID එක ඊටු ටික 1 කරාම එයාගේ broadcast ID. මොන දැන් එකක් දුන්නා. දැන් මේක ඉතුරු 1 1 1 set එක ඉතුරුයි දැන්. ඒකෙනුත් අපිට ඕන නම් අපිට ඕන පොඩි subnet එකක් ගන්න අපිට ආයෙ ඕක කරන්න පුළුවන් ඕන නම් 0 0 මෙයාට දීලා ඉතුරු ටික ඉතුරු කරගන්න පුළුවන්. එතකොට අපිට තව ගොඩක් ඉතුරු වෙනවා. හරි. So then this is the subnet ID and broadcast ID of that. So then we have these IP addresses available. එහෙම කැඩුවොත් එහෙම මේ address range එක තාම අපි ගාව ඉතුරුලා තියෙනවා. පස්සේ ඕන වැඩක් කරගන්න පුළුවන්. එක subnet එකක් හදන්න පුළුවන්. ඕන ඒ subnet එක තව හදන්න පුළුවන්. 1 1 1 right 0 0 නුදුනේ 0 1 0 1 1 0 1 1 ඒ range ඔක්කොම තව ඉතුරු තියෙනවා. So අනාගතෙත් අපිට ලොකුනේ subnet හදන්න බෑ. පොඩි machine 6 5 subnet ටිකක් හදාගන්න පුළුවන් තමයි. හරි. එහෙම නැත්නම් තවත් මේක පොඩි කරලා machine දෙකේ වයිම ආය හදාගන්න පුළුවන්. හරි. So that is how you make subnet when you have different size of subnet requirements. Right? So first you have to allocate the IP range for the biggest subnetwork. Then you gradually come to the smaller one. Okay. So that is how you do it. Right. So that is where we are going to stop it. So next time we are going to do some of these questions, and especially past paper questions, because past paper question is always IP addresses. Right. අපි මේවා ගණන් ටිකක් වැඩියෙන් හදනවා. මොකද එක්සෑම් එකේ අනිවාර්යයෙන්ම ගණන් තියෙනවා තමයි. ගණන් ටිකක් හදලා තමයි අපි ඉස්සරහට යන්නේ. අපි කතා කරන ඇයි මේ private IP address translation එකක් කරන්නේ කොහොමද වගේ පොඩි කතන්දර ටිකක් තියෙනවා. දැන් අමාරු ටික ඉවරයි. හරි. අමාරු ටික ඉවරයි. ඇත්තටම සබ්නෙට් ඉවරයි දැන්. ඔය ටික තේරෙනවා නම් වැඩි සෑහෙන කොට. අපි තව question ටිකක් කරන්න ඕන. කරනකොට තමයි ඔළුවට වදින්නේ. Right. We'll stop at this point. Right. Thank you.